Welcome back to reactions. In part 5 of this unit, we're going to be talking about electrolytic solutions. We're going to take a moment away from reactions at the moment just to talk about what is an electrolyte. Electrolytic solutions are solutions that conduct electricity due to the ions that are present in the solution. The more ions the solution contains, the better able it will be to conduct electricity. We're going to talk about a couple of different kinds of electrolytic solutions, starting with ionic compounds in polar solvents, such as salt dissolved in water. So when salt dissolves in water, it starts as NaCl solid, a lattice of sodium and chlorine ions stuck together. But when it dissolves in water, the sodium and the chlorine break apart, and it turns into sodium plus and chlorine minus. Ions have a greater attraction to water than they do to themselves, or soluble ions do. Therefore, they break apart when dissolved. These are strong electrolytes. Ionic compounds dissolved in water are strong electrolytes. Here's an example with a picture. First, we have a water molecule over here on the left with the partially positive hydrogens and the partially negative oxygen. And then we have what's called a crystal lattice, an ionic solid. And notice within the ionic solid that Na is already plus and Cl is already minus. It's not a lattice of sodium and chlorine atoms, it's a lattice of sodium and chlorine ions. They have already transferred their electrons. So, when this salt lattice dissolves in water, the positive sodium ions get surrounded by the negative oxygen in a water molecule, and the negative chlorine ions get surrounded by the positive hydrogens in a water molecule. So the opposite charges attract. What about molecular compounds dissolved in polar solvents? For example, sugar dissolved in water. Strong covalent bonds within the molecule do not break apart when added to water or other polar solvents, so these are going to be non-electrolytes. They do not conduct electricity. So in my picture, I have a sugar molecule and another sugar molecule, C6H12O6 or C12H22O11, some sugar molecule. And then I also have little water molecules. So when sugar is table sugar and it's solid, all of those sugar molecules are bunched together. But when you put it in water, those sugar molecules break apart because there's nothing really holding them together. And so the sugar molecules themselves break apart, but they do not break apart into ions. Such, for example, there's no breaking apart within the sugar molecule. All the little sugar atoms stick together, all the carbons and hydrogens stick together. So water surrounds each molecule, but water is not breaking apart the molecule. Therefore, we have no ions in solution, therefore we have no electrolyte. Some molecular compounds, when dissolved in water, like, for example, weak acids, will dissolve slightly. So if you look at this is acetic acid. CH3COO is acetate, and then when you add that hydrogen in, it becomes acetic acid. But when you dissolve this in water, that hydrogen will break apart, and so we'll have acetate and hydrogen ion. What's notable about this equation is that double arrow, which means the acetic acid can turn into the acetate and hydrogen ions, but the acetate and hydrogen ions turn back into acetic acid. So the solution does not conduct electricity very well because it's not completely ions in solution. This is why these are weak electrolytes. You'll get weak acids and weak bases giving you weak electrolytes. The next thing we have is strong acids or bases dissolved in water, and really strong acids are usually covalent compounds and strong bases are ionic compounds, so the NaOH kind of follows the same thing as the NaCl did, but I like to look at them together because they are so similar. So when strong acids dissolve in water, again, it's going to break apart and the hydrogen will turn into an ion, the chlorine will turn into an ion. And notice that there's only one arrow pointing towards the ions. It does not go back towards the molecule. So as soon as you put that HCl in water, it completely splits apart into ions and it conducts electricity very well, which is why it's a strong electrolyte. And that's all we have here about electrolytes. Now we're going to talk about how electrolytes match with precipitation reactions in our next video. I hope to see you then.